All right, my wife tells me that this next company is a pretty big deal. But no, seriously, these guys are awesome. I think you may have heard of Facebook before. They do things a little differently there because of their history of technology and of kind of creating something from scratch. And I heard their story at last year's JNUC conference, and I wanted them to come back this year and expand on that story, and they've got some cool new stuff to talk about. But basically the idea is, looking for solutions that might not be out there and obvious, and making your own by combining existing technology and coming up with your own things. So I think it's a really cool story. So without further ado, it's Mike Dodge.
Thank you. So, MacIT, the hacker way. What if you had posters like this? There you go. What if you had posters like this all around your office? What if you were encouraged to fail harder, move fast, and break things? What if your manager asked you questions like, what would you do if you weren't afraid? Well, like he said, I'm Mike, and I work at Facebook. And we do have posters like that all around the office. We are encouraged to make mistakes and move fast. And that sounds really counterintuitive when you talk to an IT guy and he's telling you to move fast and break things. But it's part of our company culture to do things the hacker way. We're going to be going over some of our hacker culture and how it applies to me and my team in IT. We're also going to be going over some of the code that we wrote and how we use it to manage our systems in our environment, as well as some open source projects that we are currently using. AJ will be going over some of the data tools that we use and how we use it to get some cool stuff. So if you've ever had a chance to check out our campus from Google Maps, it says hack really big. It's ingrained into our culture everywhere. And for many people, hack could mean different things. Some people think it's juvenile criminals breaking in government services, but not us. We consider it a way of problem solving. The hacker way to us is about pushing boundaries, testing limits, doing stuff people didn't realize was possible. It's figuring out how to do more with less, sometimes with nothing at all. It's the prison shiv and not the Ginsu knife. It's MacGyver and not Bond. It's function over form, and it rarely asks for permission or validation, but on occasions will ask for a fire extinguisher. It's as simple as putting peanut butter and jelly on a tortilla because you realize you're out of bread. It's the belief that there's always another way. Now, with that definition, it's actually pretty broad, isn't it? Many of you guys are sitting in your chairs right now and thinking, maybe this applies to me. Well, I'm telling you, it does. Some of the products that we use and some of the products that we purchase won't always work perfectly for you. So you're going to have to think of creative and solutions to fill in the gaps. Like Kevin mentioned earlier, I went to JNUC and I've been to a few meetups in the area. I've talked to a lot of people in this audience, and I came away with a few things that I wish I could just tell everyone. So that's partly what this slide is about. One of them is I see all of us working very hard, sometimes too hard. We're writing these linear scripts in some cases for a very niche, specific thing that you need to get done. And you work tirelessly to get this done. You walk away, it's your baby. You're so proud. But this is cool and all, but it's not scalable. And the worst part is the guy sitting next to you, or the guy a few rows behind you, is working on the exact same problem. I equate this to works of art. Sure, they're pretty, but maybe somebody's interpretation isn't so pretty. Maybe some are downright scary. But they're all solving the same problem, and it's a little bit about this effectiveness over elegance. But I equate this to Sisyphus, who's the Greek guy that was sentenced to roll up the boulder up the hill over and over again, only to see it come crashing down time after time. There's a better way. We need to stop looking at our scripts like they're beautiful works of art and start breaking them down into the most smallest pieces, considering them Legos. Taking each of the little pieces that you've either built, borrowed, maybe stole from a friend, and make your own modular pieces of art. And that's why I'm here to say today, stop scripting, start coding. Replace the word with coding with however you'd like, but think about it. Maybe it's programming, maybe it's engineering, but it doesn't need to be linear scripts. So what does that mean? One thing that I think is just necessary from the very beginning is version control. How many people here are using version control, like Git, Mercurial? I was really hoping to see more hands, but if you talk to any one of those guys or us, they'll tell you how important it's been. And even if you're not using it now, and even if you only have a few scripts, start using version control. A year from now, you're going to thank any of the people that you talked about using whether or not you should use Git. We personally use Git, and it has saved us so many times. The intern wrote something 2 months ago, and we can't figure out what lines he changed. It was working before. Why did it stop? Version control is big. If you haven't installed it, or start using it today. Okay. So make it simple. What does that mean? Everyone talks about documentation. I'm sure your manager does a lot. Why isn't this documented? Well, if your code is well written, if it's simple enough, it's self-documenting. Name your function something that makes sense. Block your codes into logical units. When you write a piece of code, it should be very clear what's going on. You shouldn't need 10 lines of comments. It should be exactly what you're writing. Like an example would be, you write a function that does a check on whether or not this machine is a laptop, and the if statement is no longer if, system, blah, blah, blah. It's just if laptop. It's very clear. Anyone would understand what that means. Break everything into the smallest parts. We talked about that. It's modularizing all your code. Use the right tool for the job. We're going to be going over some examples today, and a lot of it's Bash, but we currently don't use Bash as the coding language of choice. But just take a look at the problem, ask anyone else that solved the same thing, and ask yourself, what's the best tool for the job? Don't try to force a wrench to be a hammer. Reuse and share. This is another big one. I don't know how many times that I've spent weeks or late nights trying to solve a particular problem, and then I do a little bit more extensive of a Google search, or I ask a friend in the same role at another company, and they're like, oh yeah, I did this. Could have saved me tons of time. So one of the first examples that I want to touch on of something that we did was a lesson we learned pretty early. So let's pretend we forgot about some of the stuff we just talked about. And I just wrote this cool linear script that does a few core things. Doesn't matter if you can't read it, because that's not important. But if you look at any one of the blocks of code, it's pretty useful stuff. And before you know it, you're going to be using it in script after script after script. And maybe it's been a year since you wrote some of this, and you've copied it in several different locations. What happens if one of those blocks of code breaks, or you change a file path? Now you're going to have to update it in sometimes several places. What if you forget one? What if there's a syntax error? This is stuff that you shouldn't have to deal with. One way is to modularize your code, like we talked about. It's breaking things into small functional bits, storing them in a central location, and then using them as needed. But if you were to just do this, this presents some of its problems on its own. Now you have to remember, well, where did I write that function? What was the name? What file was it stored in? As your code base grows, you're going to have dozens of files, hundreds of functions, and you're going to need some way to organize it, right? Well, what if you didn't have to organize it at all? With AutoInit, it's a script that we wrote that essentially you just put that one line at the top, or you can include it in a function that you'll source over or use over and over again. And this will take your entire code base and get it into one global namespace. Why is this important? Well, you don't have to source any individual function anymore, so it cleans up your code readability. You're not source this file, source this file, source this file, then use these three functions. It's just use the functions. Get all the clutter out of the way. But this also allows you to move much quicker. Every time you use a function, you shouldn't have to ask yourself all those questions that we were before. So this one line is pretty simple. It's, is AutoInit defined? No? Then source AutoInit and run AutoInit. And now you have everything you need. Any constants that you may have set, any functions you've already previously defined, you're ready to go. Okay. So many of us are paying for a client management system. And sometimes it'll work for you, and you'll just have no problems. We have 10,000 clients, and we noticed that in some percentage of the time, some of our machines would just become unmanaged, or users are removing it themselves. So we wrote this elaborate way of trying to bring back the management system whenever it disappeared. But what we really needed was the ability to run code locally from the machine outside of our management system whenever we wanted, on scheduling it as easy as we would, say, something with Google Calendar, or, booking a conference room. So what if it was that easy? We wrote launch daemon init. Launch daemon init is basically just a bunch of launch daemons. Who here's used launch daemons before? Okay, good. That make this a little easier. But basically, it's root, and you give it a set of instructions to do something when. In this example, we have 5. Startup, every 15, hourly, daily, weekly. There will be a launch daemon running at that interval. And what do? They all do the same thing. They're all going to run the same script, which is called launch daemon init. But what is in that script? Well, the secret sauce is really just these lines here. It's a case statement. All of you guys have used case statements before. But it means that if I wanted something to run on the startup, all I do is run this script here. What about weekly? Same there. Run this then. Now, launch daemon init comes with a few handy functions built in. One of them is LDI function run, but there's also LDI shell run and LDI Python run, which just takes care of how you would run any of those individual scripts. You pass that a script name, it'll do it. Or you pass a function that's defined in your code base, and it'll automatically run it. In startup, we're running a wait for corp, which it will wait for the corporate network to be found, and once that's available to you, it'll run a jam verify. For us, that meant it was going to validate that the binary that was there, that you can actually do a manual trigger, that all the permissions are set correctly. Our users like to remove execute permission from the binary. So now there's a little bit of fancy stuff under daily, but this is just to set a random interval. We actually have our daily trigger hit at 10 a.m., but you don't want 10,000 clients checking in all at once, so it does it over the course of 4 hours. But yep, easy as scheduling something on your calendar now. Okay, so now you have a local code base. You have local scripts firing whenever you want them to. But how do you update any of that code? Well, let's pretend that the machines on the right are your fleet. Well, your life is easy. You only have 3 machines to worry about. But the machine on the left is your fancy machine, and with all the code that you just have written, and you want to get it to the rest of your fleet. How are you going to do it? Well, if you remember my first slide, I'm telling you to use Git for your version control. But we don't just use Git. In order for something to get checked into Git, it has to go through Fabricator first. And the reason being, you don't want to have to necessarily trust yourself, your coworker, with just blindly checking in code. You need someone to take a look at it for you. Fabricator is an open source project that Facebook open sourced a few years back, and it's pretty cool. It allows you to have your coworkers look at it very easily with a nice GUI. It shows in the red that we're removing stuff, and in the green we're adding stuff, and it's very easy. So they can quickly look at your code. But once they accept it, it gets moved into Git, and great. So now we have our code in Git. So what's next? How do we get it to our fleet? For that, we wrote CodeSync. CodeSync essentially just uses an SSH server. It's pretty simple once we break it down. You do git pull, and now all the latest code is on your server. You can do some other fancy stuff with checksums and all that, but let's just use git pull for today. Next, all of the machines run CodeSync, which is a function that is wrapped around rsync. Because of the way rsync works, it will only bring delta changes over. So you're not downloading the whole entire code base, only the delta changes. And you can run it basically as frequently as you want because it's so lightweight that it's only going to grab changes, and if there are none, then it'll go pretty quickly. So let's break down CodeSync and actually show you how you would set it up. You make a utility account. We call ours util. It's an unprivileged account. It can basically do nothing. We put that on the SSH server. Next, we generate a public-private key pair for that user, and we deliver the key to our fleet. Now, the public key is where the secret sauce comes in. The public key will only accept the private key if you are running rsync in one direction, from the server to the client. So if you're trying to SSH in or do any other fancy magic, it won't work unless you're using rsync and from a particular directory from the server to your clients. So next is going to be adding the SSH server to the SSH known host for your client machines. This will make it so that your fleet of clients will only accept CodeSync calls from your individual servers. No man-in-the-middle attacks there. And then, like I said, because it just uses rsync, you can run it as many times as you want. So yeah, it's pretty easy. I'm actually really happy to say that all of this stuff will be open source very soon. If it's not available right now, hit refresh, it'll be there. That's our GitHub link at the bottom. Cool. Thanks. So this next slide is really my full disclosure slide. We talked about using the right tool for the job. Some of the examples that we showed are currently written in Bash. But we also use Python, AppleScript, Objective-C, and even now Ruby. And it's important to mention that, yes, we use these tools regularly, and we rely upon some of the Bash stuff that we wrote, but we're not going to force it to try to do other things. I don't know if any of you have ever tried to decode JSON using Bash, but it's near impossible. We use Python for that sort of stuff, or most things. Python is actually our choice language right now. It's better for error handling. We'll show you an example of that right now. And readability. There is community agreed upon standards like PEP8. And when I look at one other person's script on my team or maybe at another company, assuming we're both using PEP8, I should be able to read it from the get-go. So we talked about some of the error handling. You're not going to be able to see this pretty well, but I'm defining num as an int. I'm defining num2 as a string. I try to add them together, and I will get a stack trace error telling me that I'm trying to combine an int and a string. With Bash, I might get error 365 or whoever know what the hell it's talking about. It's not going to be clear. But with Python, it'll tell you specifically what file, what line, and what kind of error you're seeing and why. So another thing that's great about Python, and a few of the other languages that are up here, is it's widely used. And we use it in conjunction with something called Sentry. Sentry is an open source tool that aggregates all of your stack traces or any errors that you have in any of your scripts and reports it to a web UI so that you can see how many people or how many nodes in your environment got a particular error in the last minute, and you can see exactly what the full stack trace is so you understand what piece of your code is breaking right away. It works with a bunch of different languages. Python and Ruby are big on the slide. And then, so we've talked about a lot of the stuff that we wrote today, and many of them are all logging to our syslog, and we do some really cool data stuff that AJ is going to talk about next. Okay. Cool.
All right. Thanks, Mike. So I'm going to start off with a question for everybody. If your manager asked you, how many of your users have had kernel panics in the last week? Would you be able to tell them? How about in the last day? Or what about maybe even the last hour? Do you know how you would get that data quickly? I do. Does your manager like charts and graphs? Of course he does. He's a manager. Right, Steve? Data can drive serious impact, and I'll show you how we drive serious impact using data at Facebook and how you can apply it to your own jobs. My name is AJ Chand, and I'm a client systems engineer, and I work at Facebook. So how many of you use Splunk or some type of a log congregation system in your environment? Okay, not as much as I thought. So yeah, this is gonna be really awesome. So make sure you guys pay attention. You'll get a lot of value out of this. So a log congregation system is basically a method that you use to take all of the Macs in your environment or other devices. You put their logs into a central location. Once they're in the central location, you can run analytics and get various types of intelligence information about how your fleet is running. Splunk is one that we use internally. It's based off what they call the SPL, or search processing language. I look at it as a hybrid of Bash and MySQL, and we'll go over some examples of some queries that we use. And again, you can feel free to use any log congregation system that you feel fit that works with your environment. This is a quick overview about how it works. On the bottom, you would have your Macs. They would send their logs off to what we call Splunk indexers. And once the data is on the indexers, you can search them from what we call the Splunk search head. That's basically where you would go ahead and put the queries that you want to get data from. So why do you care? Again, Splunk's another tool to get more data. It's another tool for you to get data for your environment so that you can make better decisions in your environment. You can actually pull real-time logging and real-time data. So an example of this would be, you guys remember when Mavericks came out last year, and everybody wanted to get it. And what we did was we supported Mavericks day one, and what we wanted to do was see how many people were actually going to install it. And so we needed some type of a solution that would give us the ability to count this. So in our installer, we wrote hooks that would write data to syslog so that we can query it in Splunk, and then be able to run real-time queries that would tell us, per hour, per half hour, per day, how many users are actually installing Mavericks. So we actually have install rates, and we can tell how fast the population is actually installing this. Culture at Facebook is very data-driven. If you have an idea or you go to a meeting, you need to be able to back up what you say. And having Splunk gives us another tool that we use to do that. Splunk generates various graphs and alerts that you can use. One example is Mike mentioned the launch daemon init, or LDI, and that runs on all of the Macs in our environment. And what we do is we can actually count the number of Macs in our environment that are running it, and we have a Splunk query that does that. So it runs every night, and it counts the number of Macs that are running it in our environment. And if that number drops below a certain threshold value, we'll actually get alerted, and it'll automatically generate a task for me or a member of my team to go figure out what's going on. And the value here is that we don't have to practically look to see how the solution's running, but rather Splunk will just give us an alert and tell us, hey, something's broken, go check it out. And of course, if someone comes up to my desk and asks me, where'd you get this information, I can just quickly make a chart in Splunk and show them, hey, check out my sticker. So we talked about Splunk, we talked about log congregation systems, but now we need to figure out, well, how do we actually write data to syslog to be able to grab from Splunk? Luckily, there's a tool called Logger. It's built into the Mac, and you can use this tool to write data into a format that Splunk is going to expect. So if you typed in Logger, and in the terminal on your Mac, if you typed in Logger -t CPE testing, you would see an entry like you see there. So you would have a date, a host, a tag, and a body. So the -t in that command stands for any tag that you would want. And once we have that data written in syslog, we can easily query it with Splunk and pull it in our queries that we might create. So let's go over an example. So let's say you wrote some cool code that does something really, really awesome. But your code can have a variety of air conditions. And you want to be able to measure each of these types of air conditions. So let's just say you do some code, and then there's a value air that's defined somewhere in your code. If the error is no VPN, we can log the logger and say that, hey, there's no VPN access. Or if there's a lack of hard drive space on the, on the user system, we can say there's a lack of space. The user may not be bound to 80, and there can be a variety of other errors that you can imagine that could potentially happen here. A quick thing to note here is that notice that the way I've written the error messages is error colon what the error is. This is going to be important for the next slide where I actually break down the query that I'm going to use to be able to count each of these types of errors. So this is basically the query I would run here. This is going to be a little confusing if you haven't used Splunk before, but I'm going to try to walk you guys through it. So we have host equals star means any host where the process is my app. So you can imagine your syslog has tons and tons of entries, right? What we're doing is we're just taking out of all those entries, we're looking for just the process of my app, and that's the one that we've written with logger. From those entries, look for a body that says error colon. So we're going to look at that string, and the next value, put it into, in this case, a lowercase variable called error. Do the same thing for success. So find the process of my app, and if it says success colon, put that into a variable called success. And then take the sum of all those and put it into some type of a graph. So when you do that, you're going to get some type of a graph like this. This is a pie graph, but you can graph it however you would like. And you'll be able to see in your environment of the script that you ran, how many times was it successful versus how many times did you have various error conditions. So I can say discretely, without a doubt, this script here was successful, but the biggest error I had was that most users weren't on VPN, so hey, I might have to communicate and send an email out telling people, hey, you have to get on VPN or before you install this particular application or whatever it is. But it gives me granular data about how my script is working. Let's say that you have some type of a GUI that you make in your environment, and the GUI can have a variety of buttons that the user can push, and you want to track how the user is actually using the application. What you can do is basically you can tie the event of the user clicking the button to creating a entry in Splunk. So for instance, in this case, if the user hit snooze 5 times, I would increment a variable called snooze and have 5 written on it. So the entry that you see on the bottom there, it'll say like details equals 0, snooze equals 0, install equals 1. This means that the user has hit install 1 time. If snooze was 5, that means the user hit snooze 5 times. And what you can do once you have this information is you can count up each of these values throughout all of the Macs in your fleet, and you can see how users are actually interacting with your application. So in this case, I ran a simple Splunk query, and I seen that in my whole environment, install was hit 564 times, and snooze was hit 2,890 times. That means users are pushing off the update, and I need to actively communicate and see, hey, why are they pushing it off? Maybe I can push this update at a better time, maybe get feedback from my users and see what I need to do. So we're starting to use a new tool called Monkey. Does anyone here use Monkey? Cool, awesome. Yeah, we started recently using it here at Facebook, and for those that haven't used it, it's a tool that lets you automatically deploy Apple software updates and also deploy applications as well. It's written by Greg Neagle, and you can get it at the URL that we have down there. And so what we wanted to do was see, hey, what kind of data could we extract if we started looking at the logs that Monkey generates? And so this is still an experimental area for us, but what we're able to do right now is we're able to count and see how many times users are installing any particular application that we offer in Monkey. So for instance, on this graph here, you can see that on the y-axis we have the different applications that we're offering through Monkey, and the x-axis is a count of how many actual installs that we have. So in this case, we can see that most users are installing software updates. But imagine if you have licensed software on here, and if you see a big bar, that means a lot of people are installing it. But if you don't, that may mean that you can potentially not have as many licenses in a particular application, and you may be able to save money or move those licenses to another application that can provide more value for your company. We're also looking to see ways that we can figure out how long it is before a user actually installs an update. And that's still an area that we're still experimenting in with Monkey. And I think this is probably one of the coolest things we're doing. When you guys think of a typical help desk scenario, the way it typically works is that a user will have a problem, and they'll have the problem, they'll just forget about it, they'll deal with it. They'll have the problem again, they'll deal with it. They'll have the problem again, they'll deal with it. And then finally they'll get pissed off enough to actually go to the help desk, and they'll go and get the problem fixed, right? Well, what if you can flip that idea around? Instead of making the help desk a reactive type of place, what if you can make it proactive? What if your help desk folks can actually reach out to users before the users even know they have the problem? Well, we're starting to experiment with doing things like this at Facebook. And we're doing it by monitoring kernel panics and Outlook issues. And I want to give a big shout out to Joshua Mack, who works on a help desk team, who's helping to lead this initiative. I think he's doing a really great job. I think he's somewhere in the audience. I don't know where he's at. But so what we can do is we can run a search query in Splunk that looks for the process called dump panic. Dump panic is the process that runs when the Mac kernel panics and it writes a syslog entry. And what we do is we actually search for that entry, and then we're doing a stats count by host, which means find all the Macs in my environment, and for each Mac, tell me how many times it's crashed. And with this, we rerun this report every 2 hours, and every time there's data in that report, we assign it automatically to the help desk, and the help desk will go and proactively reach out to a user and figure out if they're having kernel panics and help solve the issue for them. This is pretty much a win-win, right? We increase user satisfaction. So far, the feedback in our environment has been awesome. A lot of people are actually shocked that we can even do something like this. Proactive support, again, we're changing it from a reactive system to a proactive system. And that's ideally the way you would want it to be. You save the user time because the tech can just go look through the logs, and then before they actually reach out to the user, they can get other tickets and other information about any potential issues the user might have had before even involving the user, which means that the whole process takes less time. And so the user has less interaction with the help desk, and it's just a quicker process. You save time. And again, it's a completely automated system. We're also doing the same type of thing with Outlook queries as well. And one of the issues in our environment is that Outlook will sporadically crash. And so what we're doing is we're looking for a particular entry in the log that says, exited with error code 15. And we're actually doing the same thing there. And this is what the Splunk report's going to look like. You're going to have a bunch of host names on your left, and then the count of each one on the right. So you can see that, like the first host there, it crashed 55 times. And so that's probably a problematic thing, right? So you know how to actually figure out which systems in your environment are having issues. So takeaways. Mike and I have a couple of things that we want everyone to take away from this. One, as I just kind of went over, data can drive some serious impact. We went over the whole kernel panic issue. We're taking action on the data, and we have it done in an automated fashion. Impact can be measured, whether you have a GUI application or you have anything else in your environment. We can measure how users interact with systems that we have, and log congregation tools can give that type of information to us.
And next, we've already talked about this before, but it's stop scripting and start coding. Reuse and share. Find a community that you can join or appreciate, and bring back the knowledge that you're learning. We're all solving the same problems. Let's make all of our jobs that much easier. So speaking of that, there's a group that we started called the IT Think Tank. It's available on Facebook. So if you go to /group/the IT Think Tank, you can join there. There's also some other good communities, and we talk about that, about meetups and who found out how to install Homebrew from root, stuff like that. That's our GitHub again, one more time. We're now in IRC, and that's our webpage. So now we still have a few minutes for Q&A. They've asked us to tell you guys to go to the mics if you have any questions. Let me know. No questions?
Any questions?
Rich, we'll try to repeat your question if you don't want to walk to the mic. All right.
So I wanted to ask about, with regards to the self-documenting functions, one of the values I found in comments is the fact that I'm not always the brightest guy on earth, and I like to write comments in my code to make sure that I can't possibly misunderstand what I was doing. So have you guys ever run into issues where someone looked at self-documenting code and said, what?
So maybe I should expand on that in general. My scripts, unless it's doing something fancy, have very little comments. The functions themselves, the utilities that they're using, it's documented very well. Sometimes I include the Stack Overflow link that I found it on, or sometimes it's default, like just stuff I copied straight from the internet. This is where I found it. But in my general scripts, some of them are as short as 5 lines because it's if laptop, do this. If desktop, do this. Now, what is the do this? It's file vault or something like that. But if you want to go look at that function, who knows? It could be like, you know, pages of documentation or links to maybe your site.
Okay, so the distinction you're making is basically your function should already be well documented. If you need to go back and take a look at it, that's where the documentation is going to be. In the script itself, just maybe have a brief description of, you know, I'm doing this function. If you need more information, go look at the function.
Well, I've instructed my team to know where to look, but yes, you could do simple things like that. And a lot of this will be up to your own team's interpretation. We try to standardize, which is I think is the big thing. If I look at one script or another, doesn't matter who wrote it, it's going to be written in a similar fashion. Some of us use all the same vimRC, so we know exactly, like it'll have the exact same amount of spaces, or you know, with bash syntax, sometimes it's the then is on the same line as the if or whatever. We have a set of standards that we choose to stick with and try to propagate that through any of the scripts we write. And I would encourage you guys to actually sit down, or if you haven't yet, with your team and just kind of like, what's best for us? How does this work for us? Does that work for you? Have you guys done that where you're from?
Yeah, mostly. I mean, I'm the guy who's writing most of the scripts in my shop.
Okay.
Yeah. I also wanted to make one comment. Thank you very much for posting the stuff on GitHub. I've been wanting to take a look at how you guys have been doing like the self-healing Jamf re-enroll since the last Jamf conference.
I'm sorry it took so long. Some of it was just because it wasn't documented.
In regard to the Splunk stuff you have set up, can you go over like how much data you're talking about and what environment you have for processing all the logs, and how many clients are in your node,
Yeah.
your environment?
So one of the things I forgot to mention in this is that I'm assuming that the Splunk infrastructure is actually set up, and we have a different team that actually sets it up in our environment. So I couldn't give you the details on that, but I'll leave it at that.
We have 10,000 client
Yeah.
nodes that are all
Yeah.
checking in with all of their client logs. Splunk isn't the only option, though. There's some other open source stuff. Do you remember any of the names?
There's Loggly, Greylog, I think, and there's some other ones as well.
Yeah. It's more about how we were just suggesting that log aggregation is a powerful tool within itself, not
Sure.
necessarily which one you should use.
I was just curious about how much data we're talking about in general.
Yeah, we don't have that actual
Okay.
information.
Sorry.
Thanks.
Any other questions?
Hi, I hope this question
Oh,
isn't
hey.
too specific, but I was looking at your launch daemon that you showed up there, and it was waiting for the corporate network. I was just wondering how your system functions when a machine is off the corporate network.
Oh, so yeah, that's actually one of the reasons why we wrote LDI. I thought I mentioned it, but let me just expand on it a little bit. We found a problem when Jamf binary was broken. How do you fix it if your deployment mechanism is Jamf? So it was like the chicken and the egg. So what we did was we kind of have LDI as our plan B. The launch daemons are actually running locally, and they're sourcing all the code that lives locally. CodeSync will put it in a particular directory, but also validate that it's only like read and root executable. So it's all in its own little container and self-contained because it's self-updating outside of your management system and can be used to fix that said management system if it breaks or if a user breaks it. Yeah. So what's up? What's your question, stranger?
What's up, Wes?
how are you guys planning on managing the Oculus devices that you're going to be onboarding
Oh,
soon?
come on. Oh, stop. I don't know anything about it. I wouldn't even be the right person to talk anything more about that. Stop trolling. All right. Anything else?
Can you explain what that was?
Oh, he's making a reference to a company that Facebook is acquiring that does VR glasses.
Hi, how about a non-commercial version of Splunk? Is there something out there?
What is that?
A non-commercial Splunk.
I think they do have a free version. I think that it's limited in the amount of bandwidth that you can use. But you can definitely try it out, and they have a free solution that you can try.
Okay, thank
Yeah.
you.
Cool. I think you got there first. In the back?
Hey, just curious, is Open Directory or Apple Remote Desktop ever in a mix of your client management solutions at all?
So we have some very strict security policies. We have firewall turned on for ARD and SSH, so you can't actually get to the machines through any of those means. We do some stuff where, like, if we needed it on a particular machine, we can turn it on, but by default, it's not. So those particular tools aren't very helpful.
I just want to make a comment regarding so using Logger and syslog with Splunk or whatever you're using it with. There's definitely value. Also, you can parse existing logs for maybe system management tools you have, or maybe security tools, and actually get better value out of the data coming out of those applications by pushing it through Logger. So
Yeah, for sure.
Thanks.
Anything you can log, you can get data value from. So.
And if anyone doesn't know, this is Arik. He's from MacBrain. There's going to be an event soon. Tonight, sorry. So reach out to one of us. We'll give you more details. Any other questions? No? Who's going to go and install Git when they get back?
Everyone, come on.
Yeah, Git. All right. Or Mercurial, whatever. Okay.
All right, thanks, guys. Thank you so much, Mike. AJ.